There we go. So it wasn't going because it had an update message for me. Okay, so today what we're going to do is go over a topic that I feel like that, well, first off, for some reason, the slides don't really have it in it, and I'll double check, but I don't think the slides necessarily go over it that well, or if at all. I didn't see them there when I was checking. But today we're going to go over multidimensional arrays, right? So that's arrays of arrays, which sounds really complicated, especially when you throw in a mathematical term like multidimensional in front of there, right? Multidimensional sounds terrible, which is why when it's not actually as terrible as that, so it just makes you sound really smart when you get to say, oh yeah, I learned about multidimensional arrays today. So, they're not really so bad if you understand how arrays are working. So if you're understanding how arrays are working just fine, then hopefully it's not too bad. Because the idea today is that what we're going to do is, the slides don't cover it at all. What we're going to do today is go over what happens if you want to, have a collection of arrays, right? Arrays. So let's go ahead and, open this up and go and see, it's an intro. We want to go into code, and we're doing arrays. Basics, so where is that? Windows, View, Restore Default Layout. View. Come on. No, I don't want that. I don't need help. I need new Java class, name, multi-arrays. Yes. All right, so we've got a file here that goes over multidimensional arrays. So first thing we need to do is create a public stack void main to just have a place to work with it. Okay? And let's see. Project. There we go. So what is a multidimensional array? So let's first just remember what an array is. An array is a collection of integers. So, a collection of a bunch of different types, right? It can be whatever. Like here's an array of ints. So I'll just call it numbers. It's equal to 1, 5, 7, 8. Oh, 9. Can't type. So there's a collection of numbers right over there. It can also be a collection of just any type we want. So I could make a collection of strings called words, right? Which we've done before, and said basically that we've got like hello and world and an exclamation point, right? These are all just this is just a collection of stuff, right? So we can just group stuff together. So let's just take a look at string words for a second, right? What is a string when you get right down to it? String, individual, right? Is equal to this is a string, right? Nothing too complicated there. Okay, but a string at its core, right? We say it's just a nice big layer to make it easier to work with multiple characters, right? Because traditionally typically you don't want to work with one character at a time, right? Imagine, you remember you were working with with the project you were working on last week in class, right? And hopefully most of you got to the file reading part of it. Can you imagine what kind of torture it would be if you had to read one character at a time, right? Can you imagine that kind of torture if you just had to read every character at a time and like, okay, I read this character. Oh, there's a space. Okay, so now I need to turn those two characters into a single number, right? Could you imagine the torture that would be, right? As opposed to being able to read one string at a time and then convert it into an integer. So that reading in basically strings, dealing with strings makes it a heck of a lot easier. But if we remove that layer of abstraction that we created for ourselves, what is a string? A string is a character array. car letters is equal to string dot to character array. Let's go ahead and do let's print out arrays dot to string letters, right? And now let's go ahead and run this. And so, right, this is a string gets printed out because I turned that string into a character array. Notice how basically it's just a bunch of characters all separated by commas. Okay? It's just a bunch of it's a bunch of individual characters. Okay? So really another way to think of this string array words is that basically inside of words we have one string, which is an array of characters underneath. We have another string, which is an array of characters underneath. And then we have another string, which is an array of characters underneath. Although that third one isn't particularly interesting because, of course, it just has one character in it, right? But these are, so the entire point of this is that since we've dealt with arrays of strings already, this is what I'm about to hit you with isn't actually new, or rather complete. It's going to be new, but not completely new. So it's stuff you've already had to deal with, right? Right? If I give you an array of words, right? Let's go ahead and solve a problem two different ways, okay? So suppose I wanted you to write a function in the upcoming timed lab, right? So something along the lines of public static int num vowels, right? And we've done this problem a bit before, just with a single string, right? A single string, right? I asked you, okay, given a word, right? Can you please count the number of vowels in this word, right? And return that integer, right? So now let's just, kick it up into the next gear and say, okay, given an array of strings, okay, so given multiple words, I want you to count the total number of vowels in all the words, right? In all the strings I give to you, right? That makes sense to everybody? We've done just one, now we're saying multiple strings. So, however, it still starts out and ends the same way. So let's go ahead and just do this and think about the starting and ending. So the first I need is to count the number of vowels, right? Num vowels, okay, is equal to 0. The second thing I need to do, and then at the end, I'll be returning num vowels, right? So nothing too scary over there. So, so now what I need to do is I need to go through each word. And then for each word, I count the number of vowels in it, right? Each individual string in words, let's go ahead and rename that a bit. So let's call our group of strings words. So for int I is equal to 0, I is, and generally, I don't suggest diving into anything. Right now I know I need to go through each individual string in the array, right? So let's go ahead and just work on that. I is less than words.length, I++. All right, and if I were to do system out.println over here and print out, words I, that would print out the ith word. So if I passed in this array over here, it would print out, this array would print out hello world exclamation point, right? That's what I'd do. But right now by just knowing, by reading what I have, I know what I'm doing here is printing out each of those words, right? Right, if I'm printing out each of those words right now. So I don't really need that at the moment. Okay, now for each of these words that I'm printing out here, that I don't really need to print out here, but I'm just having that just so I know I'm going through it, I need to count the number of vowels in that individual word. So I'll say, I'll store it in a variable just to make it easier. String, let's go with maybe this word, or maybe ith word, sure. Ith word is equal to words at index I, right? Or we could just call it word if you wanted to, but it's the ith word here, right? It's the word at index I, okay? And now I need to count the number of vowels in that. Now, if I had that method, right, if I already had a num vowels method that counted the number of individual words, a number of individual vowels in that individual string, I could call it here, but let's just assume I don't. So I have to do that manually. So for So what I need to do, I need to check every single character in there. So for int j is equal to 0, j is equal to, so j is less than the ith word dot length, j plus plus. It's with parentheses because length there is a method. Okay. For arrays, you use a method there, dot length. Car letter is equal to, let's see, ith word dot caret j, not I, right? Remember, when you're in a loop, one of the things that even I make mistakes about is like, you know, sometimes confusing, forgetting where I am in that and using j if I need to. So we get that letter, and if letter equals a, or letter equals e, and now we can just copy paste this, you know, and then replace it with u, o, I. I said I. Keys are like apparently right next to each other. Num vowels plus plus. Right? So we go through every letter. If that letter is one of these things, then we count we increment the number of the vowels. Then we return that total number. Okay. So here we've got 3 vowels. So if I were to do, so if I were to print out the returned result of num vowels of words, I should get 3. I don't need the event log at all. So yeah. So like I said, num vowels 3, and it printed out each individual word it was working on because that's what I told it to. Okay. So the thing is that working with multidimensional arrays isn't much different than this. Okay. So we'll revisit this in a second, but I wanted to just say that when we're dealing with multidimensional arrays, the entire concept is for each of these things has something inside of it that we also have to go through, right? Sometimes you have to say, it's like going through a grid, right? We're going row by row through the grid, but each row has its own number of elements, right? So right now, this is going to be most like dealing with matrices from math, only we don't have to remember about matrix multiplication because that's nasty. We might do matrix addition just because that's less nasty than matrix multiplication here, right? But matrix addition is fairly easy to understand. You just add the same components of the grid together, which is pretty easy. Okay, so what is a multidimensional array? Well, yeah, that's a great question because it really depends on how you visualize it. To your computer, a multidimensional array is actually just a single-dimensional array that you're just doing a hack for. Because again, remember, your computer stores everything in a giant line of zeros and ones, right? Right. So the idea of grouping stuff together in an array makes sense, and the way that your computer is going to group it up, it's also going to be a giant line. But for us, it's a nice thing. It's a way of saying that we want an array of arrays, or that we want multiple dimensions. That we're working with a grid rather than a row. So a multidimensional array looks like this. So it's now got 2 of those, right? 2 array markers next to it. I'll just call it matrix is equal to, so a new array, sorry, not new array, new integer array, and I want it to be 3 by 3. In fact, I will move this into its own example. Actually, I'll just comment these out. So maybe for these guys. So there we go. We've got a 3 by 3 array, which I'm calling matrix. Okay. Now, so what does this mean? It means that essentially that we have multiple dimensions here. We have a way to address it. Let's go ahead and let's go ahead and see what happens if we print this out. So system.out.println. I mean, let's just experiment with it first. Now that we've got this thing, arrays.toString. matrix. So let's go ahead and print out our matrix. Oh, arrays.toString, right? Okay, that looks a bit weird. What is that? It's saying, okay, so I see an outer bracket. Sorry, I see an open bracket and a closed bracket at the beginning and end of this, right? So those are, that means that this is a group of array, and then we see an open brackets without closed brackets. So bracket I, oh, right, that's what happens when you print out an array, right? So saying we've got an array here as the first element of this array. We've got an array here as the second element of an array. And we got a third element that's, the third element array is also an array. And this I means that they're integer arrays. And here's their memory locations where they start at. So this means that essentially that we've got an array of arrays. Now that sounds a bit weird, but don't worry, I'm going to give you plenty of metaphors to help you with this, because metaphors are the best way for dealing with these things. Okay? So when we're dealing with multidimensional arrays, maybe this isn't the best way to do it. What about, like, there's a different method, though, but it's not necessarily always the greatest to use. So there's a deep toString, which is specifically made for arrays of arrays, where basically it says, okay, we're going to go into the array, and then we're going to print out each of those things. So our first array in there is 3 zeros. Our second array in there is 3 zeros. And our third array in there is 3 zeros, right? Because that makes sense. We're creating a 3 by 3 array, right? That makes sense to everybody? It's 3 by 3. So we've got 3 outer elements, each of which have 3 inner elements, right? Of course, the way we like to think of those are maybe rows and columns. But let's go ahead and just see how we mess with these things. So matrix, let's go with 0, 0 is equal to 1, just to see that we change something. Oh, I guess that comma notation doesn't work. Instead, what you do is you use it just like you would over here. Matrix 0, 0, so the first dimension and the second dimension over there. I always like to think of it as row column. So there's row 0, column 0. It does 1, 0, 0. Notice how it only changed the 1 in this array, right? Let's go ahead and see maybe row 1, column 0. So let's go ahead and see this one. So now we've changed. So this one refers to the outermost array, right? So this first one refers to the outermost array, and this next one refers to the next innermost array, right? So you've got 1, then we've changed this one to 1. If we change this to 1, 1, this over here will change to 1. So this will change over here to 1. Rerun this. Run it. There we go. There we go. So, all right. So this is a 3 by 3 array. And essentially we know that it's sometimes easier rather than thinking. So this is one way to think of it. Essentially, you've got an array of arrays. The first one your first index gives you the first array in the list, right? Which array you want, and then the next one gives you the element of that individual element in there. So that's one way to think of it. Arrays of arrays. Okay. The second way to think of it is row column notation, which is easier if we just format this a bit differently. So let's go ahead and say, so we know we've got, okay, so we know we've got like a bunch of, if this is an array of arrays, we can iterate through the outer array and then print out each outer array. So for int I is equal to 0, I is less than matrix.length. So what is the length of this matrix? That's an interesting question. You might think it's 6 because it's 3 times 3, right? But this is an array of arrays, okay? This is an array of integer arrays, right? It might be better to think of it like this, right? It's an array of integer arrays, right? There were 3 elements in this array. Those 3 elements were integer arrays. So it gets a bit recursive, which sometimes, can get your head a bit a bit dizzy, but that's okay, is what I'm saying. It takes a bit of time to wrap your head around this. So what we can do over here though is do system. I'm just going to format this a bit differently. System.out.println arrays dot toString, and we're going to print out the ith row of matrix, and then we're going to print out. So we're going to print out index 0, index 1, and index 2. And now if we do that, it prints out in a much more familiar format to us. We've got 0, we've got 0, 0, 1, 1. Oh, this is a matrix. This is an actual bona fide matrix, right? One of those 2 by 2 things, right? At least, from your perspective, right? Over here, right? This is index 0, 0, right? Maybe in math, this would be 1, 1. This would be 2, 2. This would be 3, 3, right? But this is row 1, row 2, row 3, column 1, column 2, column 3. Although in computer science, it's 0, 1, 2, and 0, 1, 2. That makes sense to everybody? This is just the matrix you're dealing with. So another way of thinking this is that this first dimension is the row. The second one is the column. That makes sense? First dimension row, second dimension column. There's a lot of ways to think about this. In which case, maybe it's easier if I'm dealing with this, I name my variables different. Int row is equal to row.length, row plus plus, matrix row. And this is, I find whenever you're dealing with like specifically 2D arrays, it's better to use, instead of using INJ, it's almost always to your benefit to spend the extra 2 characters per variable and call it row and column instead of INJ, because otherwise your eyes will just start watering, okay? So here we're printing out each row, right? The outer layer, so we're going to print out each row. Does that make sense? We're going to deal with each row, okay? Another way to think, and so we can manipulate it though, again, each row has 3 items in it because that's what we set up over here. Each row has 3 items in it, so we can set it up so that we can do something along the lines of system, So now for int column, so for each column in the row, column is less than matrix row, column plus plus. Okay, we can now do it like, not matrix row dot length. So this is a bit to parse, but we're saying, so now for each of the indices valid, right, each row has columns in it, right? This one has has 3 columns in it, this row has 3 columns in it, this row has 3 columns in it. So we're saying for columns is going to start at 0, columns values are going to go up to but not include matrix.row.length, so the length of the row, right? So it's going to be, the values are going to be 0, 1, and 2. So now we can do system.out.print. What we're going to do is we're going to print out call plus a space, and then do system.out.println over here. Right, we're going to print it out. So we're not going to print out column. What we're going to do is we're going to print out matrix row column, and print that out over here. So now this will print out all the variables, all the values stored in this array. Okay. So again, so a couple things to note that are going to be, that might seem a bit maddening, okay? But they're caveats here. I've been using the term multidimensional as opposed to 2-dimensional, and this is because there's nothing stopping me from doing this. Right? That's the only appropriate variable for that, right? But notice that it compiles. This is array of arrays of arrays of arrays of arrays of arrays of arrays, and so on and so forth, or a 1, 2, 3, 4, 5, 6, 7, 8, 9-dimensional array. Is there a valid reason to do this? Probably not. Don't do that. Going above 3 is questionable, right? You can imagine a 3-dimensional thing, right, if you're modeling like a bunch of points on something. speaking of points, we're going to go back to graphics because graphics are a great visual tie-in for this, right? Because notice that this is 0, this area over here, this index over here is 0, 0, right? Row 0, column 0, right? And that, remember, if you remember all the way back a number of weeks ago from graphics, that graphics started with this pixel being at 0, 0, and then this one being 1, 1, and this one being row 0, column 1. So that's another thing to make sure. X and Y and rows and columns they can be misleading. So make sure you're using row and column when you're dealing with these. X and Y might give you a different result, right? Because if I say this, so if I say, let's see, matrix, matrix row 1, column 2 is equal to 5, okay? So this means over here that we go right to row 1 and then over to column 2. So we go down 1 and then column 2. But if we were thinking of this in terms of X and Y coordinates, it'd be the other way around because we'd be going over 1 and then down 2, right? So make sure that you're dealing with that you're thinking in terms of row column over here rather than X, Y. Otherwise, you might be in for a surprise, and not like one of those fun surprises either. But the why does it seem flipped kind of surprises. So this kind of variable does exist. That way lies madness. Don't do that. It's typically better to bake objects. But I mean, it's not. Now you might be wondering, how the heck would you even visualize such a thing, right? You know, you can hardly go above 3 dimensions, and that really just depends on what your definition of dimension is or what you're trying to do. I mean, so let's go for another metaphor, right? Int array x, right? You can imagine that this is a let's go ahead and say x is a bunch of numbers, right? Okay, x is just a bunch of numbers. Maybe they're stored on a piece of paper, right? A bunch of numbers on a piece of paper. Well, if I have multiple pieces of papers, that's 2 dimensions over here, right? So first piece of paper, right? Each a number on the paper, and then all those all those pieces of papers might be grouped together into a manila folder, right? One of those folders that you keep a bunch of papers in. That's a 3rd dimension already, right? So folder, pieces of paper in the folder, numbers on the pieces of paper. Each of those might be in a filing cabinet. Right? So which filing cabinet, so which drawer are you in the filing cabinet? Which folder in the filing cabinet? Which pieces of paper? Which number on the piece of paper? There might be multiple stacks of cabinets, and then those cabinets might be in different rooms, and those rooms might be in different floors, which might be in different buildings. Building, floor, room, drawer, so which stack are you in? Which cabinet, which manila envelope, which piece of paper, which number on the piece of paper, right? So it really just, so that's, we're up to, what, 8 at that point? Which is, I think, plenty far for the purpose of this metaphor, right? The matter of dimensionality, and think it just is a matter of basically what your imagination is going to go to. But honestly, going up beyond 2 is madness. So beyond 2 is not great. So we're going to avoid going beyond a 2-dimensional array. There's no point to going beyond a 2-dimensional array. Okay. And you might go into something like a 3-dimensional array indirectly when you're dealing with an array of strings, right? Because each string is also a character array. But you're probably not going to go anything crazier than that, right? So, okay. So what can we do with this? Well, we can treat them like matrices for the first part. So let's do a matrix add, let's write a basic matrix add. Public static void add. Whoops. Oh my. It's just so easy to knock this wall blister out. So this one is going to be, let's call it matrix add. right? So what happens when you add one matrix to another? You get a third matrix out that's different, right? Let's go ahead. Well, we'll define it that way rather than changing one of the matrices. So we're going to have A, because remember when we're dealing with because I'm going to use the mathematical convention when we're dealing with matrices of that you've got use a capital letter for one. B, right? Okay, and then this will return a new matrix. Okay. So the first thing we need to do is that we've got to figure out our inputs and outputs. So where are we collecting our answers? Well, we're collecting our answers into a new array which we'll call matrix C, which we need to figure out how big that's going to be. But we'll do that, and then we're going to return C back to the user. So when you're adding two by two matrices together, right? Or not 2 by 2, but two-dimensional array, two matrices together, the number of rows and number of columns have to be the same, right? So we'll go ahead and just do that. So we'll go ahead and assume that's the case. First, we'll go ahead and check if a.length is equal to b.length. So we're making sure that they have the same number of rows here, right? And a0, so the dot length, so the length of the 0th row of A, the length of the first row of A, so how many columns does A have, is equal to B dot length. So it makes sense that we're checking we're checking the length two ways. First, we're checking does it have the same number of rows? And then we're checking, do each of those rows have the same number of columns, right? Because this is the 0th row. Another way to say is that we're checking, are the number of arrays in this array the same? And then do the first arrays have the same length? Is it possible for each of the arrays to have different lengths? Yes. That's called jagged arrays, and I'll get into that because we aren't really going to use that too much over here. For the most part, you can assume that basically you're going to be dealing with matrices for the most part, which means that basically you have that each row has the same number of columns. So if they have the same number of lengths, well, let's see. Well, technically, if they don't have the same number of lengths. So if they don't have either of those, we'll return null. Right? We'll just abort the program, right? If they don't match up in dimensionality the same way, then we're just going to abort. So now we know that they're the same length. We've confirmed they're the same length, so we can go ahead and say int. We want it to have the same number of rows as A, and then we want it to have the same number of columns as the first row of A. Length. Which is a bit to read. I'll be frank with you. Oh, and we got to use the new keyword here. So we create int C is a new integer array. How big is it? Well, its rows are equal to the number of A's rows, and its number of columns is equal to the number of columns there. It's a bit to read there, right? But it's nothing to be too worried about if you just break it down into the parts. What is A.length? That's the number of elements inside of A, which is how many rows it has in the matrix kind of view. And then the columns is and this is basically, okay, let's look at the first row of A. How many columns does it have? How many elements does the first array in the array have? Okay, so now we just have to go through each item and add them. So first, so for int, and rather than using I and j, I strongly recommend using row and column. Is equal to 0. I is less than, so right, row is less than A.length. And if you need to, you can do something like this over here, where you go int rows is equal to A.length int calls. And honestly, this is even better. Even though it looks like it might look a bit novice-y, but honestly, when you're dealing with code like this, it's always better to make your code readable. So right? So now we can read this pretty much easier, this creation statement. We want the array C to have as many rows and columns as rows and columns, right? So this is a lot easier to read, right? Rather than trying to figure it out all in one line, we split that into 3 lines. And so now I can just go over here and say rows. So while row is less than the number of rows, row plus plus. And then for each column, col equals 0. Col is less than cols. Col plus plus. Okay. So now let's go ahead and now just do the actual thing. So C, row, column. So now what are we going to put in that row column combination of C? It's going to be equal to A row col plus B row col. Okay? So let's see. So now we've got to test it. Okay? So let's go ahead and make a something fairly straightforward. So now the question is that, okay, I was able to make a single dimensional array, using this. Can I make a 2-dimensional array that way? Of course you can. So let's go ahead and, interesting. Okay. Let's go ahead and make a int array A is equal to, and this time, sometimes doing this like this requires you to just be a bit forceful in how you want it formatted. But I'd like maybe to make an array that looks like this. So let's go with 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I've split it up over here like this, but let's go ahead and just look at it in the ugliness of a one-liner, okay? In its full decrepitude, so to speak, right? So let's just see this. This is outer layer. So let's look at this outer layer first off. This outer layer where the braces are highlighted, that is an array. What is it an array of? It's an array of integer arrays. Okay? It's a 3 by 3, just like our examples, right? It has each of these, so it's an array of integer arrays. Each integer array, has 3 elements in it, right? First one has 0, 1, 2. The next one has 3, 4, 5. And the next one has 6, 7, 8. That's how your computer interprets it. But if we were to break this up into something more readable, right, with just using the enter key to do it, we can look at it visually and say, hey, it's a 2 by 2 matrix, right? Does that make sense? There's multiple ways to look at them. Each of them are valid, right? So let's go ahead and make integer b something pretty easy to deal with. Let's just make it an array of 1s, or a 2D array of 1s. B is equal to, so now we need 3 1s, another 3 1s, and another 3 1s. And your IDE will probably help you format them to get them all in a row like that. So now if we do, let's go ahead and say, let's see. Let's go ahead and comment this out as well, because then I think I'm going to try to transition to graphics, because it might be a better way to introduce this, or to show more this off a bit better. Okay, int C is equal to matrix add A and B. And then we want to do system .println arrays .toString. And remember, if we did arrays.toString, it will just print out the address, then the address of the address. So we want deep toString in this case. But most of the time, you can use, if you did that in an exam accidentally, I wouldn't hold it against you. It's a lot easier if you just print out each row in, using a for loop. So maybe I'll do that instead. So for, and I'm actually going to use my for each loop here, which I mentioned. For each integer row in C. So for each integer row in C, system.out.println arrays.toString the row. So now I print this out. We get 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's the correct answer because we had 0 through 8 over here, and then we went ahead and added a bunch of 1s to that, right? If we add a 0 over here, right, we should get 7, 7 on the bottom. Okay, so 2D arrays are useful. Maybe if you're collecting data on a bunch of data points. You can imagine, like for the project where you're counting the numbers, a 2D array would actually be kind of useful because right now you have to run your program to go over the 0 digits, then the 1's digits, then the 2's digits, then the 3's digits, right? So a 2D array, you don't need this for your program, but you can, because it's only testing you over single dimensional arrays, right? But you can imagine for the program you've been working on that you could have an array, you can have a multi-dimensional array. The first row has all the 0th digits. Then the second row, then it has all the 1's digits on the next row, and then the next row after that has the 2's digits. So you can look at all the data all at once, right? So 2-dimensional arrays are pretty useful when you need a collection of collection, right? When you have a collection of data, when you have multiple collections of data is a better way to put it. Because collections of collections, that's kind of recursive, and that's never really easy. So multiple collections. So let's go ahead and go and check out. First, let's go ahead and make sure that we get something working here. So let's see, project. Okay. So let's go ahead and look at some, let's see, intro. We had code. And then we had, I think, drawing. Nope, that was not it. Graphics, right? So we had, going back all the way, right, we used the graphics library to do this, right? Everybody remember that? And as I go down, my Y position goes down, although technically that's the row, but we'll get to that in a second. And we use the drawing panel to do that, right? Which is a whole bunch of things that gives me access to a graphics. So now I get to show you some interesting stuff in there. And right, so you need to be in the same, if you're going to follow along with me on this one, you'll need to be in the same project as the graphics example, or you'll have to copy the graphics example over into where you're working. So I'm going to just do this in the graphics example over here. So pixels example. Okay. Yes. Okay. And I'm wondering, I think I did this in Eclipse as well. I'm just going to double check my workspace there because I haven't. Nope. Was it in teaching? Did I do it in here? I'm just checking something really quickly. Nope. Okay. So I'll open up Eclipse and double check in there, but I think I had something that I just didn't copy over here. So so let's go ahead and do public static void main. Now we'll eventually, maybe once if I have time left in the class, and I think I will, which is why I'm going over graphics I've been going over graphics in a haphazard way, is I think I'll have plenty of time left because believe it or not, after arrays, technically I have just 2 more chapters to do, although they're a bit of a doozy because they require a bit of a change in the way we've been doing stuff in terms of thinking, but they're going to be plenty fun because we can actually start, because the change of thinking is the change in how we organize programs. So how can we do things that require multiple files and stuff like that? So let's see. Do we have teaching or grading? So Java. Do I have something over here that was? No, I think it must have been somewhere else. Oh well. I guess I'll just have to do it by ear then. So, right, what we had to do here was that we had to create a drawing panel in order to get access to a graphics object, right? The entire point of this is that the authors of the textbook have this thing called a drawing panel. And if I run the program, it just creates this, essentially this canvas for me to work on, right? And the entire point I said was that I'd like my, the entire point of this is that it obfuscates a whole bunch of steps that are overly complicated, in my opinion, to give you access to the graphics library. Graphics library, so graphics G is equal to panel.getGraphics. Okay. And then we could do some fun stuff on this graphics, right? We could fill a rectangle and we could say I wanted to start at, I want us to start at location 50, 50, and I want it to be a rectangle that's 10 wide and 90 high. And I like this about IntelliJ. This is one of the reasons I switched, is because it's got the those notifications of what my variables are. Right, x, y, width, and height. So I do that, and I can just draw a rectangle there. But what is this canvas when we get right down to it? So g dot get, let's see if I set up a integer array will give it to me. Int array pixels is equal to g dot, let's see, does it give it to me? I'm looking for, no, it's not giving it to me. Or is it panel.get pixel. There we go. So we've got, so interestingly enough, if we go into panels, they've got a couple of things in here. First, get pixel, which would return a color, right? Because remember, with an image, right, with an image like this, essentially how are images displayed on your computer, right? Just a 1-minute recap, right? Every image on your computer is a little square, right? If you just take a moment to look at your laptop screen, if you've got, unless you've got one of those really high-res screens, you can probably, just get in really close and look, and you see, oh, there's individual squares that make up my screen, right? Okay, and the smaller the screen and the higher resolution, the harder it is to see those squares. Okay, but those are pixels, and that's how a computer displays images to you, right? And each of those pixels is a certain color. What is a color? It's that's actually a really hard question to answer. What the heck is a color? That's actually a really hard question to answer, believe it or not. But for our purposes, it is a combination of 3 integers. It is a red, a green, and a blue. Okay. So pixels are red, green, and blue. Are red, green, blue. So here we've got this pixel. It has that my arrow cursor is on. It says it's pixel 5325 has a red of 255, a green of 255, and a black of 255. Whereas over here, since we're drawing completely black, this one says it's 0, 0, and 0. Right? That's what a color is. It's just combinations of red, green, and blue. Okay. So if we wanted to, we can actually set these things manually, right? G dot, so let's go ahead and say panel.get pixel, right? Said, give me the pixel at 51, 51. It's going to give me, that will return a color C. And then if I do system, let's go ahead and write that actually. G dot drawString color, or sorry, we'll draw there, and we'll draw it at 100, 0. So x is equal to 100, 0. And then does it need a any other arguments? Let's see. Oh, right, I'm passing it that, so I need to turn it into a string. So now it should write what it is over here. Oh, too big, right? It just went over there, so I need to move it down a bit. 40. So it says it's a so its color is java.auth.color with red, green, and blue each equal to 0. Okay? In other words, it's black. So I can get an individual picture like that. But not only that, now that we know about two-dimensional arrays, I can get an entire canvas of color. Go ahead and close this. So let's go ahead, because this is an array of each of those pixels is defined by a color object. So we can get an entire array of these things. So color pixels is equal to panel.getPixels, and that will return an array of pixels. Could also have done, let's say, panel.get, let's see what else they have, pixels RGB. Okay. And now that's just a bunch of colors. So now what I can do is I could say, let's say I want to set every other column. So let's go ahead and just set one of the columns completely equal to black. So let's go ahead and get the top row, right? Pixels 0, that's going to be the top row of pixels, right? So color array is equal to top row. And let's go ahead and just set that all to red. So for int I is equal to 0, I is less than top row dot length. So basically go through all the valid indices in that array. I plus plus, and there may just have to be one more step after we do this. Top row I is equal to color dot red. And now let's see if that even does anything. Does it do anything? No, it doesn't, because I believe I have to, it created a copy of pixels, so now I think I have to do panel. I'll go back and explain the set. Yep. Just making sure this works, because I've done it before. There we go. Okay, so what the heck did I just do there? But we saw what the end result was, so let me move this out of the way. End result is now we've got a line of red going over the top, right? Okay. So g.fill. So here we first created our rectangle, and then next we had this, which said get us pixels. Remember, each pixel is a color, right? So that's why it's a 2D array of colors, right? Because this is a 2D array of colors over here that we're looking at, right? It's a grid of colors. A 2D array basically is used for anything that's a grid. Make sense? So when you work with if you're getting into graphics, you expect to work with 2D arrays a lot. But don't worry if it's scary right now. It will become, secondhand. So we got the top row, right? Why is this the top row? Well, because this is row 0, row 1, row 2, row 3, row 4, and so on and so forth, right? These are each of the rows. Think of it as a matrix. So then we said for everything in the top row, let's turn it to red. Now it didn't work the first time, because what I had to do was that I had to tell the panel to set those pixels, right? I got it. I kind of got a copy of the canvas. I made my changes, and then I handed it back. So here I was handing it back, right? In fact, if I put in a delay by using a nice command here called panel.sleep in int milliseconds, let's go ahead and give it a 1000 millisecond delay, or a full second, right? We should be able to see if I run this, it's not red, it's red. That's pretty cool, yeah? So So let's go ahead and see what else we can do. Maybe we can, why don't we like, so here's the next step maybe. Why don't we go ahead and like go row by row, you know, and turn each row red. Actually, each row sounds a bit boring. Why don't we do every other row? Okay? So first off, let's go ahead and just simply deal with the whole, how do I get every other row in this column of pixels? So we've got pixels already, right? We've already done this, right? So notice how I'm just taking a problem like that was small, like turning the top row red, and now let's go and do every other one. Okay, so first we need to just go iterate through all the rows. So for int row, right? Better to think of this in terms of row. Int row is equal to 0, so we're going to start row 0. Row is less than pixels dot length, right? Because that's how many rows are in there. Row plus plus. So this will get every single row in there. Okay. So then color. So remember, each row is an array of colors, right? Just a 1D array of colors. So I'll call this one current row is equal to pixels dot. So this way, if I do this, it's going to be easier for me to manipulate than having to go, okay, it's pixels row, right? That doesn't make nearly as much sense as setting this up and saying, okay, this is the current row I'm working on. Okay? So now what I can do is I can work with the current row and basically say, okay, and I'll worry about doing like every other row in a bit. Okay, that can come later. Current row is equal to, so now we have to go, so current row is a bunch of pixels, right? It's each individual, it's a 1D array of color. So let's go ahead and do color. Actually, so 4. Let's go with for int column equals 0. So for each pixel in the current row, column plus plus. Okay. Now let's go ahead, and now that we've got it, we can go current row is equal to current row, I was just reading something else. So current row column equal to, let's say, color dot red. There we go. And that's enough to change it. So I don't need to do something like this, by the way. I don't have to go I don't have to do the reverse operation. I don't have to say pixels row is equal to current row, because remember, we're dealing with memory locations over here. So we made a copy of the memory. This got us the memory location of the current pixels. So we don't need to store it back, because they're both this is the same thing as this. They're the same thing, so I don't have to resave it. Okay, so now that will turn everything red, right? So let's go ahead, and this should just turn everything red, or not, right? Because I have to do the whole panel dot set pixels to pixels. So now that should set everything to red. Okay, which is not as interesting as you know, as it could be. So let's go ahead. Yes. We're going to do that now. We're building up to it. But you're exactly correct. That's what we're going to do. So now what we can do is that we're going to do a panel. So once we set an entire row to red, we'll do panel dot sleep. And why don't we give it 1,000 milliseconds over here? So now it's going to basically just cascade down every second. Or, oh, no, it's not, because what we have to also do over here is that it sleeps and then it goes on to the next row. But once we color a row, we want to redraw it. So here we'll do okay, so we've modified the top row of pixels, apply it, then go back to sleep, then go and sleep for a second before you do the next row. So we don't need this over here anymore. So now it just slowly grows over, right? This goes pretty slow because, of course, it takes a second between them. So why don't we go ahead and kill that process and go on maybe and make it run 10 times as fast. That's pretty cool. Okay, and that will just overwrite, you know, that over there. So that's pretty cool. Okay, so now how do I do this for every other row? Well, as you might imagine, we're doing row plus plus over here, right? That goes from one row to the next row. So we could go and do row plus equals 2 over here. Fairly straightforward. Right? That makes sense? Row plus equals 2. So we go from 0 to 2 to 4 to 8. So now if I run this, right, and skipping every other row there. So that's pretty nice. All right, so what else can I do? Can I animate it going across? Let's see what happens. I'm sure I can. So what if instead I put this in here, inside of this one, where we're going column by column? Okay. So now it goes across like that. Let's go ahead and remove the panel.sleep here and see how quickly that goes. So it goes across, and then it goes across again. It just keeps so it just keeps going across now, 1 pixel at a time, like that. Okay. Now, is there a way we can kind of do like maybe a checkerboard pattern instead? That means that we'd have to skip every other one over here, right? So that means we should do plus equals 2 over here. So now let's go ahead and try to do a checkerboard pattern. Is everybody still with me on this? So checkerboard pattern means basically we want to do, let me go ahead and just make sure. How many pixels are these still running? Stop. Okay, stop. How many of them do I have open now? All right, so let's go ahead and see. So now we've got like a checkerboard pattern going along. It's going to take longer, so why don't we go ahead and go back to doing it row by row in terms of animation. But this is kind of how basic animation can work. Okay, there we go. And that's more of a dotted pattern, right? Rather than a checkerboard pattern. Right? For it to be checkerboard, we need each row to be offset from one another, right? Evens on one. Right now, we're making every even red, but every other row should like be evens and odds. Okay, so what we need to do is something along the lines of, right? We need to do every column, but let's see. And then we need to do also for it to be checkerboard, we need to also do every row. Let's see. So here right now we're back to turning everything, you know, red, right? This will turn everything red again. Okay. So terminate that, terminate. So now let's go ahead and see over here. If we do plus equals 2 over here, essentially we've got vertical lines going down now. So how do we get from this to a checkerboard? Let me zoom in. Well, maybe if the row is even, we do offsets. We offset one way and the row is odd, we'll offset another way. So what we'll do over here is that if row if row mod 2 is equal to 0, let's see what we do. If row mod 2 is equal to 0, then what we want to do is that So basically, if the row, so let's go ahead and just make a rule. If we're on even rows, we want to do even columns. So if row mod 2 is equal to 0 and column mod 2 equal to 0, then we'll make it red. Else, if row mod 2 equal 1 and column mod 2 equal to 1. So if they're both even, color them red, and if they're both odd, color them red. And now that should be something very interesting, hopefully. Oh, I'm still skipping like this one over here. So what am I doing wrong? Oh, because I've still got this +2 over here. Column plus. Weird. So, of course, it would never run correctly. Oh, and there we go. We've got a checkerboard-like pattern. So there's a lot of interesting things that can go on with these. So this is about basically the craziest thing I've done with a 2D array. I might do something a bit more intense on Wednesday as we get into it. But this is for the most part, I'm not going to have you deal with graphics. It's going to be dealing with like 2D arrays of integers and stuff. Now, what we're going to move on to, your big project next week, hopefully. If not next week, then the week after that will be something rather exciting, which I love doing, and it's rather satisfying for a lot of students. It's called the Game of Life. So this is what we're building up to and why we're dealing with 2D arrays. It's not the board Game of Life that you probably played with the spinner and basically and missing out on going to college and then and stuff. Instead, it's a 0-player game, which works off of a couple of basic rules based on the grid. And you can do this pretty well in ASCII, right? In fact, I have it set up so that you do it basically just text-based completely. So we render these things text-based. But there's no reason, there would be nothing from stopping you from turning this in using the drawing panel either, just by using the sleep method, right? Because you can animate things in the sleep method by it's being fairly straightforward by doing that. Let's see. How could I do that, for instance? Just make a animation go on forever. Let's see. I could basically create a counter and basically just have this flip on and off to white. So let's go ahead and see that. Just one second. So let's go ahead. So while true. So what does while true mean? It means this loop is going to run forever, right? So while true, do this, right? And then let's go with panel.sleep. So create the checkerboard pattern instantaneously, in other words. Then sleep for 1,000 seconds. Sorry, for 100 milliseconds. Then do panel.sleep. I'll go ahead and turn it into a ½ second so it doesn't get stroby or anything. Panel.draw. Fill. Graphics. G.fill rectangle 0, 0, 500, 500. Panel.sleep for another ½ second. And we could do something like this now. and it's just going to go on forever because I've got it in a while loop. Basically, it says set all the pixels up, and then sleep for half a second, then draw a black rectangle that's 500 by 500 pixels, which is bigger than the screen, so it makes the entire screen black. Then says set it, then sleep again, and then do the whole pixel thing again. So it's just a constantly animating loop that just goes on forever until I tell it to stop with either the terminate button or closing it. So you can just draw continuous animations like that in a fairly straightforward manner. So if you wanted to do it using the graphics, you could, but this is what we're building up to, the game of life, which seems like it's super complicated, but really just involves rules as to whether squares are alive or dead, and then checking the rows and columns around them. So it doesn't really require too much extra stuff. It just requires a bit of thinking about your edge cases, as you'll learn. The other thing to note about, but otherwise, I'm going to discuss with the TA today about, or our TAs today, about what the time lab would be. I'm kind of hesitant to do double arrays on the timed lab, but they will most certainly be on the exam. And the exam, depending on how these look out, they'll either be on the next week or the week after. So latest it will be is on April 6th, which is my birthday. So I guess that'll be interesting. So otherwise it will be on the 30th. But again, I'm also receptive to your needs. So if a lot of you tell me that next week for an exam would be kind of insane because of you might have a bunch of exams otherwise, please email me. Right? If next week it would be insane for an exam, please email me, and if it needs to be pushed back, okay? Because honestly, there's plenty of material to fit in there, and then once we do, I think once April 13th is over, we should have most of our curriculum done for the most part, and we'll be able to work on some really big and fun projects. And big and fun doesn't necessarily mean difficult.